Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, first of all, let me to introduce myself. My name is Yoni Kunchoro. I'm student of Graduate School 11 Maret University Surakarta. Today, allow me to present my paper entitled The Role of Silicon and Content of Proline, Protein, and Abscisic Acid on Soybean under drought stress. This paper is written based on the result of my research, which is also part of my dissertation research. As we know that drought stress is an important biotic limiting factor and affects almost all of metabolic processes in plants. So that it causes low production while the need continues to increase. This problem requires the right solution to develop crop cultivation techniques on dry land or marginal land. And one alternative solution is silicon application. According to expert opinion that the content of proline and abscisic acid in plants will increase in drought stress conditions. Some of the roles of silicon in plants are silicon is able to mitigate negative effects of drought stress. Imam et al. 2014, Zhang et al. 2015. And then silicon can increase tomato conductance by Habibi and Hajibolan 2013, etc. According to expert opinion that the content of proline and abscisic acid in plants will increase in drought stress conditions. Some of the roles of silicon plants are silicon is able to mitigate negative effects of drought stress. Imam et al. 2014 and Zhang et al. 2015. And then silicon increased metal conductance, Habibi and Hajibolan 2013, and etc. Materials and methods. This research was designed and carried out in a greenhouse, and the planting material used is a soybean cultivar grobogan. Drought stress conditions were simulated using PEG 6000 at a concentration of 15 milliliter, equivalent to minus 0.67 MPa. Proline analysis using the modified Bates method, and then analysis of crude protein using the Kegidal method, and ABA analysis using gas chromatography. As the result, correlation analysis between the silicon concentration and the content of proline and abscisic acid showed that there was strong negative relationship R minus 0.972 for proline and R minus 0.975 for abscisic acid. But the silicon concentration showed a positive correlation to contents of crude protein R 0.974. Furthermore, through the regression test, it showed that the silicon concentration determined significantly to the level of or to the content of proline, protein, and abscisic acid, each R square 0.945 for proline and 0.950 for protein and 0.952 for abscisic acid. This chart described that each increase in the concentration of silicon applied shows a decrease in soybean proline content. The treatment without silicon showed the highest proline content, it's about 4.55%, and the lowest proline content, 1.16%, was shown at 15 milliliter silicon concentration. Figure 3 explains that each increase in silicon concentration tends to increase the protein content of soybean leaves, and the lowest growth protein content was shown in the treatments without silicon, 3.78%, and the highest was in the 50 milliliter silicon concentration, 4.82%. These charts explain that every increase in the concentration of silicon caused the content of abscisic acid to decrease. The highest abscisic acid content was shown at the treatment without silicon, 0.76 microgram, and the lowest was shown at the 15 milliliter treatment, 0.32 microgram. Finally, the conclusion of my paper are: the first, the application of silicon at several concentrations showed that the increase in silicon concentration had a strong effect on content of proline, protein, and abscisic acid. And the second, its increasing of silicon concentration causes a decrease in proline and abscisic acid contents, but tends to increase crude protein content. Generally, the treatment of silicon concentration of 15 milliliter had a large effect on almost all observed variables. I think that's all, and thank you very much for your attention.